So today we will study about the solid state part 4. Solid state. Question number 13. Cesium bromide CSBr crystalline in body centered cubic lattice in BCC. Unit cell length is given, that is A, is 436.6 picometer. Given that atomic mass of cesium, so atomic mass of cesium is given, that is 133, and that of bromine is also given, that is 80 atomic mass unit. Avogadro number is given, that is 6.02 10 raised to 23 per mole. What is the density of cesium bromide? So it is asking about the density of cesium bromide. It is asked in 2006, right? So see the density formula. Density formula we know, Z into M divided by A cube into Na. Z is your coordination number. So for BCC it is 2, right? So for BCC it is 2. And what will be the molar mass for cesium bromide? Cesium molar mass is 133 plus 80. So how much it is? It is 3. It is 1, it is 2. So it will be 213, right? So put here 213 divided by A cube. A cube we know, A value is 436.6. 436.6 picometer cube, right? Into 6.023 10 raised to 23. So it will be coming out to be 4.25 gram per centimeter cube. Please write that. So mainly you have to just remember the main formula, this one, density equal to Z into M upon AQ into N. Now solve the next question number 14. So 14 number, picronometric density of sodium chloride. So it is picronometric density of sodium chloride NaCl is equal to 2.165 10 raised to 3 kg per meter cube, while its X-ray density is, so X-ray density of this compound is equal to 2.178 10 raised to 3 kg per meter cube. The fraction of unoccupied site in the sodium chloride. So you have to find the unoccupied site. Unoccupied site of sodium chloride NaCl. So look at the explanation now. So molar mass from pyrometric density will be given as, so write the first explanation. So it will be the molar volume from picrometric density. So it is capital M upon 2.165 10 raised to 3 meter cube. Right. So next statement, molar mass of the X-ray will be the molar volume from X-ray density. It will be M upon, right. So we use here formula this one, density equal to mass upon volume. So we have to find volume. So volume will be equal to mass upon density, right? For the pyrometric density, it is mass upon that density. It is given now this one. In the similar way, for the second case, for the X-ray, this one is density given. So it is 2.178 10 raised to 3 kg per meter cube. Right. So you have to find the volume unoccupied. Third step is volume unoccupied. So it will be equal to m upon 10 raised to 3. So it will be 1 upon 2.165 minus 1 upon 2.178. So subtract this one, you will get the answer. Right. So next point will be fraction unoccupied. Okay. Fraction unoccupied. So it will be how much? So fraction unoccupied. So solve that. Yes, so it will be 0.013 into m into 10 raised to minus 3 divided by 2.165 into 2.178. Right, divided by m into 10 raised to minus 3 divided by 2.168. This is 165, right? So it will be 5.96 10 raised to minus 3. This is the fraction unoccupied. So please write that. Now see the next sum. Next sum is which one? It is 15. Second order Bragg diffraction of X-ray with length is given. That is 1 lambda equal to 1.00 Armstrong from the set of parallel plane in a metal occur at the angle theta equal to 60 degree. The distance between the scattering plane in the crystal is right. So Bragg's equation I will write. So use that one. Bragg equation. It is equal to n lambda equal to 2d sine theta. So now put the value and find the distance. So d will be equal to n lambda divided by 2 sine theta. So right, n value we know that is 2. Lambda we know 1 Armstrong. Right. Divided by 2 sine theta, sine of 60. Now solve it, you will get the distance between that. So it will be 2 into 1 divided by 2. Sine theta is nothing but it is root 3 by 2. So this 2 and this 2 will get cancelled. It will be 2 by root 3 Armstrong. So calculate it, you will get 1.15 Armstrong. Root 3 value is 1.732. So this equation is very important for you. That is Bragg's equation. Now look at the question number 16. Age length of face-centered cubic unit cell is A equal to 508 picometer. If the radius of the cation is, radius is given, that is 110 picometer. The ratio of the anion you have to find. This is the ratio of cation given. R minus you have to find it. Right, it is asked in 1998. So see the relation in face-centered cubic, right? So it is the formula. So it is made in face-centered cubic. So it will be A equal to R plus 2R plus R, right? So it is like this one. So this is your cubic unit cell, right? So each atom contains the atom to its corner. Right, so total 6 faces are there. right? So suppose I am putting, I will take the front part. So here, this is the first phase in which I am putting the atom. So this is touching to each other, right? So the neighboring atom. So this will be the R and this will be the 2R, right? And this will be the R again. So put here. So cation is kept at the corner. So it will be R plus. This will be R plus. This is your R minus, means anion. So we know A value that is given, that is 508 picometer. So your formula is A equal to R plus 2R plus small r. So now add these two. So you will get 2R plus capital 2R equal to A. Right. So anion value you have to find it. Right. So anion is here capital R. Right. So this value you have to find. So it will be A minus 2R divided by 2 equal to R. So R is equal to A value, that is 508 picometer minus 2 into small r we know, right? This is your small r cation value. This is equal to 2 into 110 picometer divided by 2. So it will be 508 minus 220 picometer divided by 2. So please subtract that one. So you will get 884 minus 2 is 2 divided by 2. So it will be equal to 144 picometer. So this is the value of R minus, means anion. Right. Now look at the question number 17. An element atomic mass 100 gram per mole. Atomic mass is equal to 100 gram per mole. Having BCC structure. So it follows the BCC, body centered cubic structure, as a age length is given, that is 400 picometer. Density of element. So density equal to Z into M divided by A cube into Na. So this formula we know for the density, right? So for BCC coordination number will be 2. So put here. Right. So put in the density formula. So density equal to Z is 2. Molar mass is 100 upon Avogadro number. So it will be 6.023 10 raised to 23. Right. So atomic mass we know, this is capital M. Na value is, we know Na value I have put here. Right. So A value we know, that is 400 picometer. Right. That will be the into cube. So you will solve, then you will get 5.188 gram per centimeter cube. So we know 1 picometer is equal to 10 raised to minus 12 meters. So this will be the value. Please write it down. Now look at the question number 18. So number of atoms in 100 gram. So mass is given, that is 100 gram of atoms, right? In FCC, it is following the face centered cubic crystal structure. With density is how much? It is 10 gram per centimeter cube. Cell age length is given, that is A is equal to 100 picometer, right? So you have to just solve it. So it is asking about number of atoms, means coordination, right? Mass is given, density is given, age length is given. So what will be the volume? Volume will be A cube. So it will be how much? 100 picometer raised to cube. So eco means 10 raised to minus 12. So finally it will be getting as 10 raised to minus 24 centimeter cube. So number of atoms. Number of atoms is equal to 10 by 10 raised to minus 24. So it will be equal to 1 into 10 raised to 25. Since FCC contains 4 atoms per unit soul, right? So in FCC, Z is equal to 4 coordination number. So this is for the one atom. So total atom is 4, no? So total number of atoms in 100 gram is equal to 4 into 10 raised to 25. So it will be 4 into 10 raised to 25. So please write this one. Now see the next sum, that is one of imperfection or crystal lattice error, right? That is called imperfection in solid. So first question is, which was one of the following compounds show both Frankel as well as Scotty defects? So it is talking about Frankel and a Scotty defect. Scotty defects. So options are given, right? So first option is silver bromide. Next is silver iodide. C option is NaCl. D option is zinc sulfide. So silver bromide show both Frankel and Scotty defects, right? So please write this one. So this is about. Now look at the second question, which is the incorrect statement, right? So see, given first FeO 0.98. Fe in metal is in the excess, right? So here Fe means iron. It is in excess amount. It is in excess amount. Then the oxygen in a Scotty defect. Thus it can't have metal deficiency effects, right? Because it is in excess, so it cannot be in deficiency defects. Though the actual iron oxide exists as, so iron oxide exists in the form of Fe 0.93 minus 0.96O. So this is the iron oxide. Iron oxide in which the defects in metal deficiency defects. So it is in the metal deficiency defects. Metal deficiency defect. Right. So now see the next point, that is Frankel defect. Size of cation and anion must be larger difference between them. So what is Frankel defects? In which cations and anions anion difference is more, is or must be large, is more or large, right? So it is the result of the large size of anion which produce a small voids between them. So void